All right. Caustic soda, NaOH, can be prepared commercially by reaction of Na2CO3 with slacked lime, calcium hydroxide. How many grams of NaOH can be obtained by treating 2.000 kilograms of Na2CO3 with calcium OH2? So first of all, we need to put together a stoichiometric equation for this. So we know that there are reactants, which is Na2CO3 and calcium OH2. Those are the reactants. And we know that one of the products is NaOH, caustic soda. But then if we used up the sodium and we used up the hydroxide, we're left with other two ions, which is calcium and CO3, which is calcium carbonate. Okay, so now we need to make sure that it's balanced. On this side of the equation, we have 2 atoms of sodium and 2 ions of hydroxide. On this side, we only have 1 of each. So it would make sense for us to put 2 here. We also want to make sure that we don't need to put any kind of coefficients here at the bottom, and we don't, because they have same charge, just opposite. They have same value of charge, but just opposite signs. So Na would be +1, OH would be -1. So therefore, we don't need any coefficients at the bottom. But we do need to put 2 here so that we balance out our sodium, and then we balance out our hydroxide. And then let's just double check calcium CO3. We got 1 calcium and 1 calcium. We got 1 CO3 and we got 1 CO3. So this is checked. So we balanced our equation. Now we gotta go on and figure out the rest of the problem. So we've got 2 kilograms of Na2CO3. So we have 2 kilograms of that. And then what we need to know is how much Na2CO3, how much caustic soda or NaOH is going to be produced. So how are we going to do that? First, we need to figure out the ratio of sodium to the whole molecule here, so that then we can figure out how much mass of from the 2 kilograms sodium is, because 2 kilograms is for the whole thing, Na2CO3, and we need to isolate our sodium. Once we isolate the mass of sodium, then we will just assume that the full thing, the full sodium has reacted, and the mass of that sodium is now on this side as a product. And once we know the mass of the sodium alone as a product, in the product, then we can figure out the mass of the whole product here. So let's just start with first thing. First is we're going to have to figure out what weight percent or what weight ratio sodium is to the whole molecule. So we need to use a periodic table because we need to figure out molecular weights. So the sodium is here, and it's 22.99. So sodium is 22.99. Since they're using kilograms, we'll just use kilogram per kilomole. And then we need to multiply that by 2. And then we're going to divide that by the total mass of the whole molecule, which is going to be, again, 22.99 kilogram per kilomole times 2. But then we're going to add the carbon to it, which is, I believe, 12.01 kilogram per kilomole, plus 3, since we got O3. So we're going to do 3 times 16 kilogram per kilomole. Okay. So here we're gonna up on top, we're gonna have 22.99 times 2, and we get 45.98 at the top, kilogram per kilomole. And at the bottom we're gonna have that plus 12.01 plus 3 times 16, so we got 105.99, 105.99. And actually, since they're using 4 significant figures in the problem, we're gonna round 105.99 up to 106.0. So I'm gonna do 106.0 like this. And it's going to be also kilogram per kilomole. Okay, so now we can figure out the ratio of sodium, weight of sodium to the rest of the molecule. So the way we're going to do it is 45.98 divided by 106. So the ratio of sodium to the molecule is 0.4338. That's sodium to the molecule. So now we have 2 kilograms of the total substance, sodium carbonate, that's being used, and the ratio of sodium is 0.4338. So now we can figure out how much actual sodium, just sodium, is being used as a reactant here. So if we take 2.000 kilograms and multiply it by 0.4338, we get 0.8675 kilograms of sodium. That's 0.8675 kilograms of sodium that is reacting. And then so on the second part of it, in the product category, we're going to have the same amount of sodium that is going to be making this NaOH product. So if we know that since we know that, we need to now figure out what proportion is the sodium in this molecule, right? So in order to do that, we're going to do the same thing as we did here. There are 2 atoms of sodium, so we're going to do on top as 22.99 kilogram per kilomole times 2. But we're going to divide it again by 22.99 kilogram per kilomole times 2. Plus, we got 2 oxygens, because this 2 here is related to the whole molecule. So we multiply sodium by 2, then we multiply oxygen by 2. So 2 times 16 kilogram per kilomole, plus, and same thing for hydrogen. We got 2 times 1.000 kilogram per kilomole. Okay, so the top portion we know from up here is 45.98 divided by, so let's do 45.98 plus 32 plus 2, we got 79.98. So the proportion of sodium in this case is 57. The ratio of sodium to the molecule, the whole molecule here in weight, is 0.5749. Okay. So if we have 0.8675 kilograms of sodium entering the product phase, we now can calculate how much of the total molecule, how much total product would be making, which is 2 NaOH, right? So we would take 0.8675 of a kilogram, and then we're going to divide by the proportion of sodium that's in this product, and then we should get the mass of the total product. Okay, so we get 1.509 kilogram. So again, this is a ratio that we got for just the sodium. So if you make your proportion, this is a little bit confusing. So if you know that 0.8675 kilogram of sodium in a product, and the ratio of sodium to the rest of the molecule by weight is 0.5749, that's the ratio. You need to find out the amount of, not sodium, but total. And you know the total would be 1.0, right? The total would be 1.0. If this is 57% or whatnot of sodium by weight in the product here, the total product is 1.0. So you need to know this. So to get this is, you just gotta get 0.8675 times 1 divided by 0.5749. So that's your ratio that you set up, which basically I can skip the 1 because it doesn't change our answer. So this is what I got. I got 0.8675 divided by 0.5749. So my product weight for NaOH is 1.509 kilograms.